All right, so this is a joint paper with Mike, and it's forthcoming in the Journal of Econometrics. And it's really been incredible this year to just observe how a single spillover of a zoonotic virus in a wet market in China has caused extraordinary impacts on public health, the economy, and more broadly, society all across the world. And one particular aspect of the pandemic that I'm going to talk about today is that of panic buying. So we all live in Australia, and we noticed in March just how much other people, and perhaps ourselves as well, bought essential goods in amounts far in excess of what we would need in the near term. And this kind of panic buying also occurred in many other countries to varying degrees. And panic buying is almost a common occurrence during a disaster and a crisis. So there are a number of historical examples, such as the first two world wars, recent hyperinflation in Zimbabwe, and there was a very large earthquake near Tokyo in Japan almost a decade ago now, and there was documented panic buying in those cases. But the global scale and the speed with which panic took hold during this pandemic has, I think, not been observed before. So one possible contender is World War II, but as far as I know, we don't actually have data of how that might compare to now, so it really is, in a sense, almost unprecedented. So panic buying leads to shortages, and shortages can lead to significant welfare costs, particularly for more vulnerable groups like the elderly. So during panic buying, people spend a lot of time and energy fixating on how they can get stock of the items that they're running out of. They go to supermarkets more frequently. They might try visiting a number of different supermarkets, and it involves a lot of anxiety and stress. And if someone were to actually run out of the product, then it can lead to significant problems. You may have seen in March in Australia, the media was writing articles like, what are 10 possible substitutes to toilet paper if you run out of them? You know, it was getting that dire. And if someone actually had to use the advice in those articles, then you can imagine it's not good for their utility function. So we know actually relatively little about the dynamics of consumer panic. When we think about the current pandemic, was panic driven by COVID-19 transmission primarily? Did the timing and severity of government containment policy also contribute to panic? So by containment policy, I mean things like lockdowns and travel restrictions and things like that. Another interesting research question is whether consumers respond to events overseas. For instance, during this pandemic, we're not only interested in what's happening in our own country, but we were also responding to what was going on overseas. We were very interested in what was happening in Italy and China earlier in the pandemic, and our media was reporting on what was going on there almost as much as what was going on here. So what do we know about panic buying? So the data company IRI this year, they released some data recently from scanner data showing a sharp spike in grocery sales during March. And this is for several countries where scanner data is available. And that is how we can kind of look at this concept of panic buying, a very large, sharp spike in grocery sales that then quickly disappears a couple of months later. There are a couple of papers in the literature. Examples are Hansman and other authors, and Erden Imai and Mike Keane. And what they do is point to some of the economic reasons for panic buying. Now, if you just think about what is an individual's optimal stockpile at home, if you were to increase the cost of going to the supermarket, that's going to lead to a higher optimal stockpile. And so, for instance, when the government announces a lockdown, you can think of that as increasing the cost of going to the store in several ways. If you're asked to self-isolate, that's going to make it harder to get to the supermarket. If you are if there's significant community transmission of COVID-19, that's going to make going to the supermarket more risky for your health. So you will think twice before doing it, and you'd want to go less frequently than normal. And if you go less frequently, that's going to increase the optimal stockpile. Another economic reason for this type of behavior might be that consumers expect higher future prices. Or the flip side of that, consumers might expect supply disruptions in the future. And if they expect supply disruptions may occur, then they want to stock up on the good now before that shortage happens. And of course, by so doing, they can cause that shortage to actually occur. And as soon as panic buying starts to happen and you start to see it in the local supermarket shelves or you read about it in the media, it actually becomes optimal in a sense for everyone else to try and stockpile before the products are completely sold out. So we saw, living in Sydney or Melbourne or wherever in March, we may not have been stockpiling toilet paper, but as soon as you start to see the stocks dwindle on the shelves, you realize you don't actually have that much left, and so you then go out and panic buy just because you want to get there before the shortage happens. And with just-in-time supply chains, it's not actually that difficult for people to clear supermarket shelves. So supermarkets, they have a strong financial incentive to try to reduce the amount of inventory they hold at any given moment, or minimize the inventory. So that's what we know thus far. So what is this paper going to do? So this paper makes what we believe to be two significant contributions. The first is that we're going to document panic buying behavior across 54 countries during the onset of the pandemic. And we're going to develop an econometric model of consumer panic and its causes. So what we're interested in in particular is how COVID-19 transmission, how the spread of the virus, and how government policy can generate this type of panic buying or consumer panic. So to achieve this, we construct a high-frequency measure of consumer panic using Google search data for the first 4 months of this year. And I'll talk about how we do that. We also collect a lot of data relating to government policy, both containment policy and economic policy over the same period. So there's a lot of data collection that went into this paper. And we hope that the model will provide some insight into how panic buying might be mitigated in the future. So we saw very recently in Melbourne just how quickly panic buying can start again. Even in Sydney, there was a week there that toilet paper stock started to go down again, and that was purely because that Melbourne was starting to see more cases, and the Victorian government was thinking about renewed lockdown. So it really does not take much for this to start again. And if you think about it might not be another wave of the virus, but also, it could be a new strain, or down the road, it could be a new spillover of a zoonotic virus altogether that causes this type of panic buying. So we need to try and learn lessons while we can. So I'm going to break this presentation down into two parts. The first part looks at how do we measure panic and how do we measure government policy, and how does this data look for a number of countries. So I'm going to show that. And then in the second part of the presentation, I'll talk about the model and show what the model implies, why panic moves the way that it does. So to measure panic, what we need really is a daily series that is available across a range of countries. We need to somehow construct this. Now, it needs to be daily because by its very nature, panic can start and stop very suddenly. And certainly government policy can also change very quickly during something like a pandemic. It's absolutely amazing to see how government was designing, announcing, and implementing the most significant economic and social policy that we've seen in decades. They were doing this in the span of a few days. And so we really need the data to kind of keep track of how quickly things change. So what we're going to do to accomplish this is use Google search data. So we're going to collect the search intensity, or the probability of people searching various terms, and we're going to try to use that to approximate the underlying consumer panic or panic buying. And we're going to collect data for 54 countries from the 1st of January to the 31st of April. So in these 54 countries is really every major economy in the world except for China. And the reason why we can't collect data for China, unfortunately, is because the government censors Google from the population from using it. So there is some literature on using Google searches to nowcast, or in other words, approximate certain types of economic behavior. So there's been examples in the literature for using Google search to approximate unemployment, things like investor enthusiasm, consumption, and stuff like that. What we're going to do is collect 10 different terms that belong to 2 different categories. So the first category are search terms that we think are more likely to be used or searched as awareness or concern for panic buying increases. And these terms are simply things like people searching panic buying, hoarding, panic, and also supermarkets. So people searching for the nearest supermarkets that's around them and things like that. The second category that we're going to look at are search terms for actual specific product categories that the IRI data, scanner data, has shown has had increased demand in March. And this is toilet paper, pasta, rice, flour, vegetables, and fruit. So the advantage of using Google search over scanner data is that it's available for far more countries and at a finer time distinction. And the way that the data is given to us by Google is Google provides a measure for the probability of a specific word or phrase being included in a short search session for a particular jurisdiction and day. So what a short search session means is an average user that's typing in maybe 2 or 3 different search terms into Google in a quick space of time. So for instance, the measurement for toilet paper for Australia on March 10th will give us the probability that if any Australian were to sit down into Google and type a couple of search terms, one of them will be toilet paper. And that got close to 1% at its peak, so it can be quite significant, these probabilities. So we're collecting data for 54 countries. We're collecting Google search data for 54 countries, and many of these countries aren't majority English speaking or even English speaking at all. So what we also have to do is translate these 10 terms into 23 other languages. And how we do this is that, for instance, for France, we collect the probability that people in France search the English term toilet paper, or whatever the term is, and then we add to that the probability that they search the French translation of toilet paper, or whatever the term is, and we add them together for the variable. So what we have at the end of this exercise is we have search probabilities for these 10 terms, and we need to find a way to combine them somehow into an index of consumer panic. And we think the best way to do this is to allow for a type of data-driven weighting. So we're going to do factor analysis to see what kind of underlying movements can explain the movements in these 10 terms. And we actually find that these 10 terms load very cleanly onto 2 common factors. And here I show a table of what the factor loadings look like. Now, if you haven't done factor analysis before, that's fine. All I'm trying to show here is that these first 5 terms, toilet paper, panic buying, hoarding, and supermarket, they all load into the second factor, which we call the panic factor, and I'll get into why we name them this way in a second. And the other 5 terms, and supermarket too, but for instance, pasta, rice, flour, vegetables, and fruit, they all load onto another factor. And so there's a very clean distinction between the 2 sets of words, with supermarket loading on both factors. And so the next question is, what are these factors and what are they actually measuring? And so this is what we'll try to do next with this figure. So what this figure does is chart the average value of this panic factor and search factor for the subset of countries that we also have scanner data for, and this is the US, the UK, Germany, France, Italy, and Spain. So we can see from the IRI scanner data what happens to grocery sales over this time, so we can see how closely our factor that we've calculated compares to that, and how similar they are. So the first thing you'll note in the panic factor is, as we saw in the scanner data, there is a very large increase towards late February and into March, and then a very huge spike around mid-March. And this is where the factor reaches its peak, and then it quickly dissipates down to pre-pandemic levels by the end of April. And this is exactly what we see when we look at the large spike in grocery sales from scanner data. They peak in mid-March and then quickly go back down into April. And so this is why we call it the panic factor, because we believe we've done a good job in using these Google search terms to approximate what's happened with grocery sales over this time. Now, this second factor does something quite different, this search factor. It stays flat until mid-March, and then it starts to significantly increase. But unlike the panic factor, it remains very high into April and then to the end of our sample period. And what you'll actually see is that this tracks quite closely what has happened to e-commerce or online grocery shopping demand when lockdowns have been implemented. So as soon as lockdowns are implemented, people shift their shopping behavior and more people try to buy groceries online. And that explains why this factor goes up to become very large and doesn't decline very quickly at all. Another noteworthy thing to notice is that this search factor bounces up and down a lot. And what this is actually doing is, this is the weekend. So during the weekend, people shop online for groceries more, and this search factor is really picking that up. Whereas the panic factor seems to be much more like what we're trying to measure, which is underlying consumer panic. So what we're going to do for the rest of the paper is we're going to take this panic factor that we've calculated for 54 countries. We're going to use that as our panic index, and I'll start calling it panic index from now on. So what this next graph does is it splits our sample of 54 countries into 3 different regions: Europe and North America, Asia. Asia includes Australia and New Zealand, and the rest of the world. South America, we have some countries in Africa as well, and Central America. And what we see is quite a bit of heterogeneity in the panic index between these regions. We notice that Asia starts panicking before any of the other regions, and that happens early to mid-February. And this is around the same time that COVID-19 cases are starting to peak in China, and cases are starting to be recorded in other Asian countries and Central Asian countries like Iran, South Korea, and Japan. And so that's what explains why Asia panicked before everywhere else. And then when we get to the end of February and into March, we see another increase in panic in 2 of the regions, the Asian region and the Europe and North America region. And this is around the same time that cases are starting to spread into Italy and Spain. And we're starting to see significant community transmission in Europe. And of course, everything comes to a head in mid-March. So in mid-March, this is where most of the countries of the world, or most of the advanced economies of the world anyway, are starting to lock down and implement very strict travel restrictions. And this is also where community transmission of COVID really starts to spread throughout Europe and North America. And we see that Europe and North America has the largest peak in panic. Asia has a very large peak in panic as well. Now, interestingly, the rest of the world also panics at around the same time, but to a much lesser extent than Europe and North America. Interestingly also is that all 3 regions, panic declines almost to the same extent by the end of April, almost to pre-pandemic levels. So we're going to look at some examples from specific countries in a little bit. But before we do that, I also want to talk about how we measure government policy over the pandemic. And this is a bit tricky because there was no official data sources for any of this. So we had to comb through media reports and things like that to try and put together measures that captures a few different dimensions of government policy over this time. And what we ended up deciding on was considering three types of government policy. The first are what we call internal movement restrictions. And this includes things like the closing of schools, restrictions on gatherings, working from home requirements, and restrictions on internal movement generally, whether people can go out and do whatever they want. And I don't have I'm not going to put up the exact definition of this variable and how it's constructed, but it is constructed methodically, and you can see details in the paper. But this variable ranges from a 0 to 5 scale. Now, the second variable is travel restrictions, and that's going to look at things like border closures with specific countries that happened earlier in the pandemic, such as China and Italy, or blanket travel restrictions that have been applied to non-citizens or citizens. And this variable ranges from a 0 to 8 scale. The third is a simpler variable, which is just stimulus announcements. And this is just the number of significant fiscal or monetary stimulus measures that have been announced by the government to prop up the economy. Now, importantly, we're going to measure policy change at the time of their announcement and not at the time of their implementation. As we think when they're announced, that's going to be the most likely time that they will generate panic. So here's a graph of how they kind of look. Now, we split the sample up according to the same three regions, and we plot the average of the different policy variables from January to May. And if you look at all of them, you'll see that most of the action happens in March, but there is some important heterogeneity between regions. For internal restrictions, we see that the Asian region starts adding internal restrictions quite early, from late January to March, but they also arrive at a lower kind of equilibrium level than the other two regions do by mid-March and into April. And we also see by the end of the data, we're just observing the start of the unwinding of lockdowns and other restrictions. And so the indices come back down a little bit. For travel restrictions, it's a very similar story where Asia starts restricting things earlier. And for stimulus announcements, we also see that the Asian economies take a more incrementalist approach. They announce more stimulus, they make more stimulus announcements for smaller amounts, whereas the Western countries tended to do very large to make very, very large stimulus measures. So what the graph doesn't show is that even within regions, there is a lot of heterogeneity in policy between countries. And so what this graph shows is the timing of these policy announcements. So what it measures for each of the three different types of policy variables, the number of policy announcements that were made on a particular day. And we see for internal restriction, we see for all of the three policies really, that most of the action again happens in March, but there is some important heterogeneity. So there are policy announcements being made in February and in April, and even within March, we see that there are a number of countries that make their policy move, or the majority of their policy move earlier in March, and some that do it later in March. And so it'll be interesting to see how these change. And so what this graph shows is kind of the first attempt to try to do that, to tease out whether this heterogeneity has any effect on panic. So what we do here is we take two groups of 7 countries that we think that acted to contain the virus quite early, and 7 others that acted to contain the virus quite late. And we chart the panic index in gray for these 7 countries, for both groups of 7 countries, and the average internal restrictions as well on the y-axis as well. And what we see is that in the early countries, now the early countries here include Austria, Belgium, Ireland, Italy, Hong Kong, Norway, and Romania, we see that panic spikes at the exact same time that the large lockdowns are being introduced. So there is a very clear association between panic and the announcement of internal restrictions. But if you consider the late countries, and the late countries here include India, Mexico, Qatar, Singapore, Sweden, the UAE, and Vietnam, they locked down on average later in March, and we see that there is not this clear association anymore between panic and the announcement of policy. The panic in these late countries also spiked around the middle of March, before the majority of the internal restrictions were announced. And when they were announced, we don't see a clear spike in panic levels. So what this might be saying, and what our contention is, that we'll try to model later, is that the effect that internal restrictions have on panic depends on the international context. If they're made very early in the pandemic, what they do is they send a very strong signal to people about how severe the pandemic might be, and that leads to a lot of panic. Whereas if the internal restrictions are announced later, when most of the other countries have already made their policy change, the policy announcement no longer has this kind of effect on the consumer's beliefs about the severity of the pandemic. They've already panicked from what they saw in other countries, and so the policy announcement doesn't have anywhere near as much effect. And I'll explain more methodically what I mean by this later, and we will test that theory. Now we're just going to look at a few examples. So the examples of a few separate countries and what panic and policy looks like for them. So what we have in the black line here is the panic index. In the gray line, we have the increase in COVID cases by thousands. And what I've done is shade the exact day that internal restrictions are announced in orange, and the exact day that travel restrictions are announced in light blue. And so what we see in Italy first is that many of the spikes in panic, or the spikes in panic in March at least, are clearly associated to policy change. So we see, for instance, in early March, this is when cases are starting to spread throughout Italy, and the government is implementing restrictions not just for the Milan region, but for wider Italy. And we see that that led to panic for a couple of days after. And then the second spike in later March seems to be associated not only with the implementation of a hard lockdown, but also a big increase in the number of COVID-19 cases in thousands. And this is the increase in COVID-19 cases. So this is an increase in thousands per day. And so both are now associated with that spike in panic. If we look at France, these associations are even clearer. So in France, they had a spike in panic in early to mid-March, and this is clearly associated with the announcement of a national lockdown. Whereas the second spike that happens right at the end of March and into April, that seems to be associated with a significant increase in the new numbers of COVID-19 cases. And that increases from roughly 2,000 to 4,000 a day, and it reaches a peak of almost 8,000 a day. Now, I can't do this without showing Australia as well. So this is what Australia looks like. And just keep in mind the scale of the panic index y-axis on the left here. So Australia reaches a peak on the panic index of 8, whereas for what we saw in France and Italy was they didn't even reach 2. So Australia in our data was really had the most dramatic increase in panic. And also notable for Australia is that it happened quite early. So it happened really at the start of March. Panic started to creep up and reached a peak very early in March. And interestingly, we can't really explain why this happened, either with policy or with an increase in COVID cases. So there is this shaded blue thing representing a travel restriction was announced shortly before the panic. What this was the government announced that people can't enter Australia from Iran anymore. And we don't think that is, significant enough to generate this type of panic. So we can't really explain why this first peak happened necessarily, because it was so large and so early. But the second peak that happens mid to late March seems to be associated when the national lockdown happened, and that was this orange bar here. Okay, so what I've shown basically so far in the presentation is our approach to measuring panic and turning these Google search terms into a panic index, and then also how we measure government policy, because what we're interested in, one of the things we're interested in is how government policy affects panic. So how would we model this panic? This is the next tricky question that I'm going to talk about and then show results for. So just conceptually, we can think of a structural equation for panic looking like something like the following, where we have panic here, P, for a given country, C, at time t. And panic, we think, is going to be a function of 4 different things. The first is it's going to be a function of what are people's expectations on the current severity of the pandemic. And so S here is the severity of the pandemic, and it's the expectation of S given I, which is their information set. So what are their beliefs that have led to them to form this expectation? That's going to partly determine panic. Another thing that panic will be a function of is the expected future severity of the pandemic. Now, then we have this variable R. Now, R is government policy for country C at time t. And so government policy will also generate panic. And lastly, the expectations on future government policy, again, given the information set. And we have a country level fixed effect to take into account things like cultural differences and things which may contribute to this. So it's easy to forget that in March, most of us had no idea what was going on, really. Even epidemiologists were struggling to find out what is the transmissibility and the severity and even the fatality rate of this virus, and governments were struggling with the idea of what their policy response should be. So when the governments and epidemiologists were still trying to figure out things, and so the average consumer is certainly not going to have any clear knowledge about how bad the pandemic was and how bad it's likely to get. So these people, what they try to do is form an information. They have an information set that they use to try to form expectations on how bad the pandemic is and what they think government policy will be, and that will determine their panic. And the information set is going to be the combination of a range of things. For instance, the number of COVID-19 cases, which we call C here. Now, they're going to look at not only the COVID-19 cases in their own country, but also COVID-19 cases overseas. So Italy is a great example of where everyone in the world was looking very closely at what was happening in Italy, because that was almost a window into what might happen in their own country in a few weeks if nothing is done. So we have this C variable subscript F, and when you see subscript F, that just basically means what's happening overseas. So the information set is a function of COVID-19 cases and government policy. Government policy, both domestic and foreign. Because people, when governments, for instance, announce there's a lockdown, people take that as a signal for how bad the pandemic might be. They might think, oh, it's just like another flu, and then they see that the government announces a hard lockdown on the economy for a month or two. And when you see that, you would then think, oh, wow, these people are taking it very seriously. Maybe I should take it very seriously as well. What we can do then is to substitute in this information set into the structural equation, and it gives us something like the reduced form. And the reduced form will be simply that panic is a function of COVID-19 cases here and overseas, and the past history of the COVID-19 cases, and government policy, both here and overseas. So in this framework, I'm starting to run out of time, so I'll have to move a bit more quick. So in this framework, a policy change, like let's say the government announces an internal restriction or a hard lockdown, that can affect panic through 4 channels in this framework. There's the direct effect of the policy, and this is things like increasing the cost of going to the store. The effect of the policy on expected future government policy. Then there's the effect of the policy on the expected current severity of the pandemic, and this is an important one. So this is where people use government announcements as a signal for how bad things actually are and how seriously they should take the pandemic and how much it will affect them. And then lastly, the effect of the policy on the expected future severity of the pandemic. And this fourth channel is the only one where a government announcement like this might actually reduce panic, because we know now that governments, if a government locks down, let's say early March, we know that this might actually help prevent future community transmission of COVID-19. So we might expect then that the future severity of the pandemic in our country is less than we previously thought it would be. So it's the effect, the overall effect is going to be the interplay between these three positive influences and this negative influence. And the important thing to note is that early in the pandemic, the third channel, the effect of the policy on expected current severity, is likely to be much stronger early in the pandemic. And that's because people's information sets are much worse. People don't know much about COVID-19 and how bad things are going to be. So if government were to announce significant interventions into the economy and society very early on, that will inform their information set much more than if governments announce these policies in April or May or something much later on. So what we hypothesize from this framework is that the effect of policy announcements on panic will be much stronger if the policy announcements are made early relative to what other countries are doing. So this leads to our reduced form equation, and this is what we actually estimate. I know it looks like a bit hard to kind of take in, but we'll go through it step by step. So we're modeling the log of panic on a country fixed effect, and we have here this R, this bolded R, and bolded R is just simply the vector of the three policy variables that we've constructed. And we start with domestic policy, so R subscript C, and we use it in differenced form. So this is really a shock on the day that the government announces a policy change. That is allowed to influence panic. So we have domestic policy. We also have the change in average foreign policy. So this R bar subscript F is just a simple average of what the policy variable is for all the other countries in the data set. So we allow, this allows for domestic panic to be influenced by what other countries are doing. And thirdly, we have an interaction between the change in domestic policy with the foreign policy in levels. And what this interaction does is it allows for the effect of domestic policy change to vary by how early or late it's implemented relative to the international context. So if R bar is large, this allows the interaction term to have an influence on the actual marginal effect of beta here. Now in the reduced form, we also have COVID cases, both domestic and overseas. Now, we're not sure how exactly people react to COVID transmission, so we want to make this flexible. And the way that we make this flexible is that we include the change in log, so this is the percentage change in COVID cases, and we also include the absolute change. So the percentage change will be very large early in the pandemic, and it will get lower when cases get higher and higher. Whereas the absolute change will be low early in the pandemic and large later in the pandemic. So we allow consumers to flexibly react to both. And we do the same for overseas cases as well. Lastly, we include cases in China. And we also include an interaction with the dummy about whether it's an Asian country. So we allow for the possibility that Asian countries care more about Chinese cases than other countries. And we also include lags of the dependent variables. So it's a dynamic panel data model. All regresses are different to ensure stationarity in the time series. We have 54 countries and we have 122 time periods. So let's look at some regression results now. So I showed two models. Just focus on model 2 for the time being, because Model 1 includes the domestic variables, but not the international variables, whereas Model 2 includes everything. So these are a set of coefficients that relate to internal restrictions. We see that the change in domestic internal restrictions has a positive effect on the log of panic, and it's a significant positive effect. And this variable, the next variable is the lag of the domestic change, and that is also positive and significant. It's hard to directly interpret the coefficients here because there are so many interactions and dynamic things in the model. So I will show the impulse response functions in a minute and on how these actually affect panic and the actual magnitudes of the effects. The third variable here, now this is the change in the overseas average internal restrictions. So this is controlling whether people in the domestic country respond to what happens overseas. And we have evidence that they do. So the coefficient is positive and significant, meaning that changes overseas, holding our domestic situation constant, does generate panic as well. Lastly, we have these interaction terms. And again, these are negative, and for the lag, it's highly significant. And what the negative in the interaction term tells us is that later in the pandemic, when the overseas average is quite large, the effect of domestic policy change gets smaller. So this is exactly what I was saying before. Early in the pandemic, people's information sets are much worse. So when the government makes a policy announcement, it really does change their expectations on the severity of the pandemic, which leads to panic. But later in the pandemic, it seems that what these results are telling us is that the effect is smaller, at least. So that's internal restriction. So we've got very strong evidence that internal restriction announcements drive or generate panic. Stimulus announcements, the evidence is much less. So we do have some evidence that there might be a positive effect from stimulus announcements on panic, but it's weaker. And it's intuitive that it would be weaker because the only way that stimulus announcements can affect panic is through expectations about severity. You know, as soon as government announces a massive stimulus package, people start to think, oh, this situation is serious. And that tends to happen earlier in the pandemic. So again, we see the interaction term is negative and significant, indicating that the effect degrades later in the pandemic. Now, for travel restrictions, we have no evidence that they have any effect, any coherent effect on panic whatsoever. So all the terms are insignificant. We also have the autoregressive terms, or the lagged panic terms. Those are actually quite small, which is a bit surprising, suggesting that we've either done a very good job explaining a lot of the temporal dependence in panic, or there isn't much dependence, or it's a very erratic or volatile measure, I suppose. Lastly, we have COVID cases. Now, I was talking before how we enter it as both a change in the log and the absolute change, and we find evidence that the change in the log, or the percentage change in COVID cases, is significant for both domestic and international cases. So people care about not only what's happening in their own country, but also overseas. And the absolute change is only matters for domestic cases. It's insignificant for international. Now, interestingly, with Chinese cases, we don't have a significant effect of Chinese cases generating panic. And looking at the data, this makes sense because we don't see spikes in panic in January and February in most of the Western countries. However, when you interact it with a dummy for whether the country is part of the Asian region, we do have a significant effect. And what this is suggesting is that countries that have very close relationships with China, like Japan, South Korea, Taiwan, Malaysia, and things like that, they have a higher stake in what's going on in China for sure. And you would think that Australia would as well, for the exact same reason. Now, I won't talk too much about the diagnostic tests, but all the diagnostic tests are very good. So we have no evidence of autocorrelation. We run the variables through the Sims non-causality test and we pass it. And we also show in the paper, I can't go into too much detail on this due to time, but we also show that cross-sectional dependence is not an issue. And so for all these reasons, we're using the variables in difference form. We pass these stringent set of diagnostic tests. With this model, we're really going for a causal interpretation of the coefficients. We argue that it's not just correlations or associations that we're seeing here. And just to drive that home, I can't think of any possible argument here for omitted variable bias with the policy variables as they're entered or as they're specified in the model. So we think the model is well specified. And before I finish, I'll just show you some impulse response functions. So this takes into account the lags, the dynamics, the things that are going on overseas. And we're going to look at the effects of an internal restriction shock on panic. So the x-axis is the day since announcement in the policy change, and the y-axis is the percentage increase to panic. And we have the 95% confidence interval here. And because of this interaction term, the effect of an internal restriction change on panic will vary depending on the international context. So what we do is we consider 3 different time periods for when the change is announced to see what the model predicts for a change that's made early in the pandemic, around the middle of the pandemic, or late in the pandemic. By late in the pandemic, I certainly don't mean the pandemic's over or anything like that. I'm just talking about our sample period, late in our sample period. So earlier on, we see a very strong positive effect that internal restrictions have on panic. It starts at around 20% increase and peaks at around 30% before declining over a week. And we also see this for middle of the pandemic. But if you go down to later in the pandemic, April the 1st, the interaction pushes the marginal effect down to almost 0. So we don't see any coherent effect on panic one way or the other when it's implemented late relative to other countries. So we see very strong evidence from this model that the effect of policy change on panic really depends on the context in which it's implemented. Now, very quickly for stimulus announcements, we have some small evidence that early in the pandemic they mattered for panic, but certainly later in the pandemic there is no significant effect on panic one way or the other. And we can also look at impulse response function for cases. And the way we split this up is we look at what is the average February increase in cases for domestic cases in percentage and absolute terms. And we see that the average February increase really had no effect on panic because they're very small. Whereas for March and April, we see a pretty sizable effect on panic that starts around 8% and slowly goes down over the next week. Overseas cases, though, people seem to be even more sensitive to that. In March and April, you'll see that the marginal effect, especially in March, approaches very large levels. And what this is telling us, I think, is that for the average country across our 54 countries, they were more scared of what they saw in the badly affected countries like Italy, Spain, certainly later on the US for sure, and rather than what was happening in their own country. And that was certainly true in Australia. We took what was happening overseas as very strong signals for what might happen in our future if we didn't do things differently. So just to conclude now, the paper has, we hope, made 2 contributions. So we've constructed a measure of consumer panic that is available across most of the major economies and at high frequency. And we are going to make this data available if anyone's interested in using it in a related project. And then we built a dynamic panel data model that allows panic to respond to domestic and international policy change and COVID-19 transmission. And we found very strong evidence that internal movement restrictions generate considerable panic for around a week. And the effect is also much stronger early in the pandemic. Consumers respond to restrictions announced by foreign governments, not just domestic governments. So people are highly sensitive to what is happening overseas. And we think that the results have some implications for governments and supermarkets trying to prevent the same behavior happening again in the future. So for instance, one example would be, we know that panic increases very suddenly to policy change. The response is immediate. And so you would hope that when the government announces a policy like this, there is some coordination with the supermarkets. Supermarkets can implement rationing, and supermarkets tried to implement rationing in Australia in March, but it happened way too late. Once it was implemented, all the shelves were already cleared, really. But in the future, they can implement it simultaneously with the government announcement, and that would really help. Or they could make efforts, if they're given some warning, to try to buffer up stock of essential goods in their warehouses. And we think that this research topic, now that data is available and we have such a clear example of it happening globally, we think talking about panic buying and consumer panic, there's a lot of scope for this to be an area of future research. Okay, so I'll stop there. Thank you for listening. And if you have any questions or comments, very happy to hear them.